Hello everyone. Welcome to Aviation Engineering YouTube channel. Today I'm going to teach Easa Module 15, Gas Turbine Fundamental, lesson number 2, part 1. So in this lesson we will have part 1 and 2. So today is physics overview. Alright, so if you still not watched the previous video, I will put the link, or else I will put as a card in this video. And now you can see the card, so you can watch this video. This is Gas Turbine Fundamental lesson 1, and then move to this uh, lesson. All right, so in this lesson we are going to talk about physics overview. And I want to tell, if you still not subscribed to Aviation Engineering YouTube channel, please subscribe, please share these videos with your friends, relatives, and also at the end of this video, if it is good and if you think it's better perfect for you, please hit a like button. All right, so in this lesson, I'm going to talk about definition of the mass, definition of acceleration, and definition of momentum, and definition of power, and gas laws like Boyle's law, Charles law, and effects of adding heat energy at constant volume, and also effect of adding heat energy at a constant pressure SI units. Okay, constant pressure SI units. Sorry, this one together, right? Constant pressure SI units. All right. Okay, so now let's go definition of mass. Okay, let's see. Mass is how much stuff is in an object, right? So it is a basic thing we use to measure how heavy something. So when we talk about mass, right? When we talk about mass, we are we are talking about how hard is to push or pull something, and it's like how heavy a backpack feels when you lift it, right? Especially when you go to school, you can understand about this. And when we are on earth, we call this weight, because of gravity pulling things down. Okay, you can see this picture, right? So in simple terms, mass is just how much stuff in is in something, right? Mass is just how much stuff is in something, and weight is what we call that mass when gravity is pulling on it. All right. Okay, so now let's go next one, definition of acceleration. So you can see the picture over there, moving car. Okay, so acceleration is how fast something is speeding up or slowing down, right? For speeding up we will call accelerations, and the slowing down we will call deceleration. So imagine you are ride a bike. So when you start pedaling faster, right, when you start pedaling faster, you are accelerating because your speed is increasing. But when you hit the bike brakes to slow down, that's also acceleration, but this time you are slowing down. That's also kind of acceleration, but this time it's called slowing down. So acceleration is about how quickly your speed changes, right? Accelerations is called how quickly the speed changes, right? So in simple term, accelerations tell us how fast something is getting faster or slower. Just remember, right? Okay, next go to the definition of momentum. I talk about this one in detail at the previous video, so you just watch this one and then you can have a good idea. So now the momentum is how much miles per hour or push something has when it is moving. So it is like when you're playing soccer, or when you're playing soccer, or you kick the ball really hard, then the ball keeps moving forward because it has a lot of momentum. So think of it this way. So momentum depends on two things. How heavy something, mass, actually momentum depend on two things. How heavy something, it is called the mass, and how fast it is going. It's like speed. So the momentum is depend on the mass and the speed. So if something is big or moving fast, it has a lot of momentum, and it is small and moving slowly, it has less momentum. So in simple terms, momentum in the 0 milliamperes, that the moving object okay, no, not sorry, not milliamperes, 0 miles per hour, right? In simple terms, momentum is the 0 mile per hour that moving object has based on how big and how fast it is. All right. Okay, now let's go to the definition of the power. So power is like how fast you can get things done, right? Power is like how fast you can get things done. So it's about how quickly can change energy from one form to another, right? To do the work that is called the energy. So imagine you are climbing stairs, right? Imagine you are climbing stairs. If you go up in the stairs really fast, you are using more power because you are changing your energy quickly. I imagine you are climbing stairs. If you go up the stairs really fast, you are using more power because you are changing your energy quickly. But if you go up the stairs slowly, you are using less power because you are changing your energy more slowly. So, in simple terms, power is how fast you can get things done, like climbing stairs quickly or slowly. So, for the equations, we can say power equal energy over time. Alright? So now let's go to the SI units. SI units is like standard international units, right? So power is measured in watts, right? Power is measured in watts, which is like the speed at which things happen. So it tells us how quickly energy is changing or work is being done. So you can also think of it as a joules per second. A joule is a unit of energy. So when we say joules per second, we are saying how much energy is changing every second. It's like measuring how fast a light bulb can turn electrical energy into light and heat. All right. Okay, you can see this one energy conversation in the light bulb. Okay, you can see electric energy is going into the electric bulb, and then the electric bulb uh, give us the thermal heat energy and the electromagnetic energy. Electromagnetic energies come like a light, and thermal energies go like a heat. So, in simple terms, when we talk about power, we use watts or joules per seconds to tell us how fast things are happening, right? Right. You can see more like length. We will use unit is meter, so abbreviation is M, simple M, and mass kilograms, kg, time seconds S, amount moles, and temperature Kelvin K, and electric currents ampere amp, and luminous intensity candela CD. Right. Okay, now let's go to the gas laws. You can see, as to really get how gas turbine work, it's super important to know about the basic gas laws. These laws tell us how gases behave when we change things like their temperature and the pressure or the volume. So it's like knowing the rules of the game before you play. Understanding these gas laws helps us know how to make the turbine run efficiently and safe. Okay, just remember, like if you're going to learn about gas turbines, the gas laws are very, very important, right? Because the gas turbine is made with the gas laws. All right. Okay, now let's go to the Boyle's law. The first one, Boyle's law. So the definition is the volume of a given mass of a gas whose temperature is maintained constant is inversely proportional to the gas pressure. Okay, just remember the volume of a gas, the volume of a given mass of gas whose temperature is maintained constantly is inversely proportional to the gas pressure, right? In Boyle's law, the temperature is constant, right? So imagine you have a balloon with some air inside. Okay, you can see you might just imagine you have a balloon with some air inside. When you squeeze the balloon to make the air pressure go up, the balloon gets smaller, but if you let the balloon expand, the air pressure inside goes down and the balloons get bigger, right? It means if the balloon is expand, the inside the balloon the air pressure is lower, right? And if you squeeze the balloon, the air pressure inside the balloon is higher, right? So when the pressure of the gas goes up, if the volume goes down, if the volume is lower, inside the balloon the pressure is up, and if the volume is bigger, the pressure is low. And when the pressures goes down, the volume goes up. Okay, pressure, if the pressure goes down, the volume goes up. This only happens when we keep the temperature the same. It means this kind of thing happen only the temperature must be constant. So it's like squeezing or stretching a balloon to change its size. So now let's go to the Charles law. So if the pressure, the definition is if the pressure of a given mass of a gas is maintained constant. Okay, in Boyle's law, the temperature is constant, and in the Charles law, the mass of a gas is maintained constant. The mass of the gas is maintained constant. the volume of the gas increases, right? The volume of the gas increases and its temperature also increases, right? So think about a balloon again, but this time it's how about how the balloons react to heat. So when you heat up the air inside the balloon, when you heat up the air inside the balloon gets bigger. But if you cool down, the balloons get shrink. So when we keep the pressure the same, when we keep the pressure the same, heating up a gas makes expand, cooling down is make it shrink. So it is like seeing the balloon grow when you blow warm air into it. Alright? Okay, so these historical laws are combined. These historical laws are combined, like Charles law and Boyle's law, combined in what is called the ideal gas law. Right? So ideal gas law made by combining Boyle's law and the Charles law, which gives the relationship like P1 V1 over T1 equal P2 V2 over T2. It means pressure, volume over temperature equal P2 V2 over T2. Like we comparing uh, two objects, right? Okay. So now the effects of adding heat energy at a constant volume. So, okay, imagine you have a seal bottle. Okay, now you can see this is a seal bottle and filled with air. So when you add heat to the bottle, when we add heat to the bottle without letting any air out, the air inside gets hotter. Air inside gets hotter. And when air gets hotter, it pushes harder against the walls of the air, right? So when the air gets hotter, it pushes hard over the walls of the bottle. So when we heat up the air inside without letting it escape, the pressure inside the bottles goes up. This is like what happens in the car engine. So when the air inside the cylinder gets hot when fuel burns, pushing the piston to make the engine go. Okay, right. So now the effect of adding heat energy at a constant pressure SI units. So you can see, think of a big room filled with air. Think of a big room filled with air. When we add heat into the air into the room, it's get hotter. And when air is get hotter, it spread out and takes up more space. So when we heat up the air in the room, it expands and takes up more room while the pressure stays about the same. This is like what happens in the gas turbine engine. The hot air expands to push the turbine's blades and create energy. So, in simpler terms, when we heat up a gas at a constant pressure, it expands and takes up more space, like how a room gets warmer and the air spread out. Alright? Okay. Yeah, you can see the turbo fan right here is the compressor. The compressor is also the same thing happen, and the air intake, bypass air, combustion chamber, exhaust nozzles, turbine. Right, so we will talk about this one later. Listen, this is the physics recap, like physics overview in simple form. All right, okay, that is the end of this lesson. Thank you for participating in this lesson. So I think you got a good knowledge about physics overview, and this is the lesson number one, part one. So stick with the aviation engineering for the part two. So the next lesson in physics overview, part two, I will upload next week. So you can wait for this one. And if you still not subscribe to Aviation Engineering, please subscribe to Aviation Engineering. And I also and one I see one person who commenting for my video. You just only read, okay? You never explain. Okay, all right. You know why? I actually don't want to just put the pictures and just puts a small note and then I read like this. Just I just only explain. But I want what I say must be included in the my like my presentation. So you know why? Because when I talk, sometimes maybe you cannot understand. Okay, so sometimes you can be missed. So but you see, the same thing I write in the presentation and same thing I read, so then the two things will goes to your mind, so it will be helpful for you to refresh, and you can keep easy to memory, all right, and easy to understand. So that is the main reason I do like this. All right, okay, so yeah, that's all for today. Thank you very much again, and if you have any questions, please comment below, so then I will try to give you the answer as soon as possible. Right, okay, so see you on the next lesson. Have a good day for all of you.